Hey folks, John with Complete Technology Solutions, your friend in the computer business. Now today we're back with part 2 of our Bake a Pie project. Now before we get started, I want to let you guys know, you probably noticed that the shooting venue looks a little different. I did actually move my studio up to a different part of the flea market here. And I'm hoping that this will improve our lighting situation and certainly our audio. You may also notice we are on Stumpy number 3. So hopefully this Stumpy will work. At this point it is actually recording, so we'll see how she holds out. This looks like a better model, no promises though. You know how we've had a track record with Stumpies lately. So, all right folks, so if you'll recall in the last episode, we are working with a Commodore VIC20. Now there were a couple of changes I needed to make, and I wanted to make sure that you guys were aware of these because it kind of came to my attention as we were doing this that nobody had ever done this on a VIC20 before. So I get to be the first, and I thought that was pretty darn cool. So here's what we're going to do. I've already got the motherboard taken out of this one. As you guys will recall in the last episode, we did that. The keyboard is still mounted along with the little LED light. So that's going to stay with the keyboard. You'll also recall that on the last episode, we talked about having to install a few different 3D printed parts, as well as a couple of hardware parts that we had to have too. So, what I wanted to do is I want to kind of let you know what the strange things were that I had to contend with before we get on with the actual build. Number one, most of the kits that you get for any type of these Commodore conversions have got some pretty decent 3D printed parts for it, but they're not really designed to do what we're actually doing. So let me show you what I'm talking about here. Now, for instance, and this was one of the biggest problems I had, this is the actual port cover and the mount for the Commodore 64 in order to put the Raspberry into the case. The problem I had is, as you can see, it mounts to the base, but since the Commodore VIC20 has such a long port here for the cartridge port, this wasn't going to work. So what I had to do is I actually had to custom design some 3D printing parts for this, starting with this one. Now, as you can see, it's the same basic mounting brackets and system, but it's got a lot longer cartridge port cover, and it had to be notched out on this side in order to accommodate the Kira. So now you'll notice when we seat this in here, what happens is it covers up the entire cartridge port. See there? And I'll see if Stumpy can see that. There. So that port will actually cover the entire thing, which is what we were looking for. The other issue that I had, as a lot of you know, the Commodore VIC20, one of the things about it is the joystick ports on the side, it only had one. Whereas the Commodore 64, as most people know, actually had 2 joystick ports. So this is what the Commodore VIC20 has. And since we both know, and all know, the Kira has got 2 ports on it, so we had to go ahead and take care of that little problem too. So what we did is we 3D printed the actual side for the joystick ports and the power connector. And as you can see, they're nicely printed and numbered. So this ought to work out just fine. It's going to end up sitting right there. So that's how that's going to go. All right, so what I'm going to do is, the first thing we have to do is go ahead and get the Kira ready. If you'll recall, in the last video, once again, we have a USB port here that it's going to allow us to connect internally to the Raspberry. Now, there are a lot of ways that people actually take care of this. Some will solder on one of the 4-pin headers that comes out. What I elected to do to give myself a little more room for cable management is I went ahead and I took some of these straight pin leaders, straight pin headers, and I went ahead and ran them through the Kira and then soldered them down on this side. So we end up with a nice clean solder and 4 pins that we can actually plug into the USB cable. Now the USB cable that I elected to use, because we did it this way, actually has the USB on one end, but on the other end, you've got these 4 pins that are color-coded. Now, the only one that is different on this one is going to be the green. There is no green on these 4. We had to use yellow. So the yellow will actually insert into here, and then we'll have connection for our USB. All right, so pretty simple stuff there. All right, that also gives us the ability to change this out, modify it a little bit, so on and so forth, later on in the project if we decide to. All right, so let's go ahead and mock this up, get an idea of what it's going to look like, all right? All right, so one of the panels we've got up here is actually going to be the one that is going to cover the old user port and the interface port. Now, the way this goes in, You actually put it in on an angle, slide it in, and there are 2 holes that will actually attach the existing screw holes in the Commodore case. So I'm going to mount that for you right here. All right, so as you can see, when these are mounted in here, this fits pretty much flush all the way across. Back here, the actual screw holes will go down through the holes, and that's where your screws are going to mount to that. The next thing we're going to go ahead and do is we're going to take our 3D printed ports for our joysticks and our power, and we're going to go ahead and lay this on here. Now, as you can see, there's actually a hole right here that will hold that in place. And then on top of that, we're going to mount our Kira. Now, one thing that I wanted to say, since I had to custom make this, and this notch in the bottom was actually an afterthought. In fact, originally, and I'll show you if I can find it here, I actually had made this piece without that notch. And what was happening is the Kira would butt up against it and it wouldn't quite fit flush. So now what should happen if I put this in place is the Kira should now sit up in here and go up under that notch in the keyboard, or excuse me, in the panel, and it should sit right in place flushly. Okay, so as you can see, what we've got is now we have the screw in for the Kira, and we have the screw in on the control arm over here, and that is actually holding the control ports in place, and the panel's actually held in place. So, at this point, what we're going to do is go ahead and mount the Raspberry. Now, that's one of the easier parts. Now, one thing you do want to do with Raspberries is there are aftermarket fans that you can actually install on these. We're not going to need one for this, I don't think so, because we've got a lot of room in here, not a lot of condensed area. However, they do come with some heat sinks that you can put on, and we are going to go ahead and apply those heat sinks. So hold on one second, I'll be right back with you. Okay, folks, so I'm going to go ahead and show you how to do this. It occurred to me that a lot of people out there don't have a lot of experience with the Raspberry. Once again, this is a Raspberry Pi B3 Plus. That's what we're working with. So what I'm going to do is I'm going to go ahead and show you how to do this, all right? So you've got one. Now, these, all of the heat sinks that come with these are just peel off, and the actual thermal compound is on the back of the actual heat sink itself. All right, and you're going to have one heat sink for the processor. You're going to have one heat sink for the video memory, and you're going to have one copper heat sink, which is actually a heat diffuser that is actually going to be applied on the back, and we'll show you that here in just one second. All right, so we've got both of those heat sinks here, got the heat sink there, and on the back, on this chip, you're actually going to apply the little copper plates that come in the kit. Okay. Now, I will tell you, I've heard a lot of horror stories about the Raspberries lately and failures that they've been having with the B3s. I have not actually had this. Then again, I will tell you that I tend to overcool my systems. So on top of this, generally speaking, I will add at least one fan. I don't think I'm going to on this one once again. We may at some point in the future just as another project, but especially if I end up going with something like an atomic Pi on this, which we may do at some point in the future too. But for right now, this is just what we're going to get. So as you can see, copper plate on the bottom, heat sink here, and everything's all nice and stuck down. All right, now, you've got your mounting plate that's mounted here that we had pre-printed for the Raspberry. What you're going to do is there's a screw hole here that will actually hold this plate in place. So you want to go ahead and screw that down. And you want to use the existing screws from the Commodore. Everything that you took out, you will be reusing. That's why you always save all of your screws. All right, so we're going to go ahead and screw this one down. All right. Now, the Raspberry mounts right on top of these brackets. Now, there's a couple of ways you can do this as well. I've seen people that actually have used those small brass inserts that you melt into the holes, and then when you melt them in there, you can then use like standard PC screws, the smaller ones. In this particular case, though, since these risers are higher, and when I printed them solid, we're actually going to use 4M wood screws, very, very small wood screws, and they're going to go straight down into the plastic to hold this down. 1 second, we'll get those in. Now the wood screws, now what I'm going to do is I'm going to show Stumpy these just to kind of give you an idea. These are very tiny. They do not have to be super large. All they have to do, since the panel is actually screwed down, the Kira assists in holding down the panel. Then these, all they do is add a little bit of extra support. So they don't have to be super long, they don't have to be super strong, They just have to be in there to secure the Raspberry down. Do not put in a screw that goes through the bottom of your case. That's one thing you're going to want to be careful of. So measure first before you put them in. I actually measured these the other day to make sure that they were right, and they are the exact right length that we needed. So, yeah, you're going to be real mad at yourself if you do this project and drive a hole through the bottom of your Commodore case. There's just nothing more fun than that, I can promise. So, all right, so we're going to go ahead and get this screw in. And as you can see, when it hits, it bites down into that. And the last one. All right, so we now have our Raspberry mounted. So we've got the Kira mounted, we've got the Raspberry mounted. For the next stage, what we're going to go ahead and do is we're going to get the cables mounted for both the HDMI output, the power output, and the power plug. Now, the power switch that we're going to be using is a basic two-prong switch. Nothing to this, nothing special. And the case cutouts actually are already in it to accommodate this switch. So, all you have to do to put the switch in is slide the switch into place, and it clicks right into place. Now you got your switch. Now, this is going to allow you to turn the Raspberry on and off externally. This is very important. You do not want to have to constantly plug and unplug your Raspberry whenever you want to shut it down. Those little, miniature plugs can break internally. They can wear over time. So this is just a much easier way to shut it down. Now, alternatively, there are actually switches that you can use that are in line with the cable. So if you don't want to install this switch, you don't necessarily have to. Just for this project, I figure I'd go ahead and do it. So show you guys how to do it. All right. So the next thing we're going to do is install the power block. Now, in the last video, you guys saw the power block. What this is going to do is it's going to connect to this remote switch, and it is going to allow us to turn the Raspberry on and off from the switch, as well as give power to the LED light up at the top. So you'll be able to see the light when this is on. All right? And the power block is actually very simple to install. It just plugs in right there. Okay, so we've gone ahead, we've got the video card, the HDMI cable mounted with our adapter for our SD card already mounted as well. So the next thing to do is to go ahead and connect the cable. That's what we're going to connect up now. And it just spins right back here and connects in right here on the Raspberry. All right, so nice loop, straight on out for us. All right. The next thing to do is going to be to go ahead and get the power connection soldered in for the power block. Now, there's a couple of ways you can do that. You can actually solder both directions if you want to, but what I actually prefer to use is one of these 2-pin pre-made connections. And as you can see, it'll actually fit right onto the power block. And there is a positive and a negative, not that it matters on the switch, because that is just a closed switch. So it's going to close and it's going to open. That's pretty much all it's going to do. All right, on the other end, you're going to want to solder these two connections to these 2 points here. So we're going to get those soldered. We'll be right back with you. All right, guys, back with you. Now, here's our soldered connections. And as you can see, those are now soldered down nicely there. Now, I will tell you, I've heard the 8-bit guy say this a few times as well. I'm good at what I do. A lot of stuff I know. I am never in the world claimed to be the world's greatest solderer. So save the comments. I understand. I do get good solid connections, though, and I do test for continuity on everything I do. So just keep that in mind. All right. And you know how it is. There's a million websites out there. There's a million different YouTube channels that'll show you how to properly solder. I've learned over process of trial and error over years on how to do it. So that's kind of where we are. So, all right. So the next phase we're going to go ahead and do is we're going to install the USB cable that is going to go to the Kira. Okay. And that cable is right here. All right. And it's pretty simple. It just plugs in right here. Now, I'm going to tell you a little something about the Raspberry Pis that a lot of people don't tell you. Anything in the top left HDMI port will always be considered player 1. So if you have multiple joysticks, multiple keyboards, any other devices, that's always going to be player 1. So keep that in mind when you do this, if you ever do this yourself. All right, on the other end, we're going to go ahead and connect these. Now, they are going to be color-coded with the exception of the green wire. So we're going to go red. And we're going to go white. And we're going to go green to yellow because that's what we have. And we're going to go black to black. All right, that's going to give us our connections for our USB. All right, so now we're going to go ahead and cable manage this. Now, I'll tell you what I may end up doing on this project. I'm not actually going to do it right now. As you could probably tell, I only cut in one extra port over here. I would like to, at some point in the near future, cut in at least one more port here to run another USB out. And I actually had prepared for that with one of the adapters, but given the time constraints and what I'm looking at here, and since I had to kind of pre-print this, I may go ahead and custom print another one and actually cut in the ports in the print. That way it'll look smooth. I won't have to break out a Dremel or end up with rough connections. So, but for right now, we're going to stay with what we've got. So I'm going to cable manage this, and I'll be right back with you. Okay, so as Stumpy can see here, hopefully she's still getting all this for us. We're going to go ahead and verify. Yep, looks like we are. All right, so we've got our cable in here. Keep in mind you need to leave the first set of jumpers free here because this is where your keyboard is going to plug in. So you want a cable management around that. As you can see, I could actually run my other USB port right here, and that's actually probably what I'll do at a later point in time. So let's go ahead and let's hook up. This is going to be the adapter to allow us to connect the SD cards outside. Now, normally I would have done this before I mounted this down, but in this case, what you could do is on the back of this, and I'm going to try to get Stumpy to see it, you can actually see it down here. Now imagine having to change that SD card every single time you wanted to change your operating system. So we didn't want to have to go through that. So what we're going to do is we're going to go ahead and get this one plugged in, and then that'll give us access to it externally. So plugs in right there, and then we'll go ahead and tie this up a little bit. Now, we don't want to get too froggy with this stuff. It's kind of small, kind of thin, but and it's not going to take up much space anyway, so you don't have to get too carried away with it. Normally what I'll do is just about like that, be just fine, and we'll get a zip tie on it. And remember, the goal here is not to crush the cables. You just want to train them, as they say, keep them in place. That's what we're shooting for. Just like that. Now, this is still a little loose because you're going to see where we're going to mount this here in a little bit. So, but for right now, we'll trim off that cable. All right, we'll move that back up in there, and it is now ready to go. Okay. Now, for the last thing we're going to wire up, it's actually going to be the power plug. Now, this is actually going to go up here to the actual block itself, and it's what's going to connect down here to external to the plug that you're going to plug in from the outside. Okay, folks, now, I made one decision right at the end here. Remember we were talking about doing the extra USB ports to give you access to the Raspberry's internal USB ports? The problem is if you go with the standard installation on one of these, you don't have any access to the other USB ports, which means that you are limited to only the joystick, the 9-pin joystick ports on the side of this, as if you were using a classic Atari joystick or a Commodore joystick, which I will be using actually. But I still wanted access to those ports. Through an ordering snafu over at Amazon, I'd actually ordered the mini USB female to male so that we could go ahead and adapt to an external port to plug in the power for the unit on the outside and run to an internal cable. They decided they would send me the wrong one. So, in the interest of continuing this project and not waiting until Amazon gets that right, what I've elected to do is, I've changed our design just a little bit. I'm going to bring Stumpy over here and show you. So what we've done is, I've gone ahead and I've wired the external USB in here up to just a small extender and over here to the port number 2, which is located right underneath the one we have plugged in that's going to the Kira currently. So basically what that's going to do is it's going to give us the ability to plug in the external USB devices. We're also going to have the ability with this build to go ahead and put in different SD cards to change the operating systems, and we'll be able to go ahead and wire up the power. In the interim, there is a small hole, and I will try to show Stumpy this, up here between the USB port on the Kira and the inside here. So I just ran a small USB mini-C on here, and I'm just going to plug it in over onto the power board, just so that we can get this project up and running and get her all tested out. Alright, so the last steps to do in this process is we're going to go ahead and connect up the Commodore keyboard, and we're going to connect up the actual LED light to the keyboard itself. Alright, so here you go. As you can see, we've got the keyboard. Nothing has been changed. It's a stock keyboard on this. And the LED plug goes right here on the power block. And it is actually coded red and black, so, and positive and negative on the block. So you plug that in, and on the keyboard, it only goes one direction, and it plugs in right here. There we go. When it comes to these mini connectors, guys, take your time. It's better to get it right and take your time than have a mistake. All right? Everybody got that? So it plugs in right there. And now we can go ahead and close up the unit, and we should be ready to go ahead and fire this up and test it and see what we get. We'll be right back with you. Okay, folks, back with you. Now, during that little intermission there, you may have noticed that a couple things changed on the workbench here. During this process, I ran into a couple of very interesting, not really problems, but just little glitches that I wanted to let you know about. I got it all working, and then at the last minute, I kind of made a little executive decision at the end, and I want to tell you a little bit about what I did here. So I've got Stumpy on this, so here's what I'm going to do. I'm going to explain to you exactly how I've got this currently set up, okay? And I'll tell you what the actual changes were and one other thing that I had found. So the first thing that I had noticed is that the LED lights were not working at all coming from the Kira. Now, I later determined two things. Number one, they were not functioning here on the Kira, but the LED itself was defective on the VIC20. So I changed out the LED to one that's verified functioning and tested it on the Kira, and sure enough, we still had nothing. So that's one problem. The next problem that I ran into, on the power block, the concept of the power block is that you've got an external switch. A Raspberry has got to be powered all the way down before you remove power from it. So just like a computer going through a shutdown cycle, it has to be shut all the way down. Otherwise, it can actually damage the Raspberry. Well, what the power block is supposed to do is when you hit that switch, it's supposed to allow it to shut all the way down before turning off the actual Raspberry. What I was finding is that even though you go through the shutdown sequence, it would still sit there and do nothing. And the switch at that point would do nothing at all. So you'd have to turn the switch off, pull the power off of the power block, plug it back in, hit the switch, it'd come on again. But the power block would not turn it off. So I needed the power block to drive the LED light. So right now, the only thing the power block is actually going to do is drive the LED. And the way I did this, and I wanted to show you this before I got it all cabled up pretty. I ran a jumper from the switch, and I want to show exactly how I've got this set up here on Stumpy. The concept of this is, this now thinks, as far as everything goes, this thinks that the switch is constantly on. It's on all the time, okay? So basically the power block is just a pass-through. So the plug is running externally, comes into it, hits the power block says switch is on, and will turn on as soon as it sees power. The other thing we're going to be using are actually the LED pins on the power block itself. Okay, so that's what we're going to be using. So I'll be tying this up nicely and cleaning up this switch, or rather this jumper, just to keep the power block on. The LED, on the other hand, I had to rewire a new LED. So this will actually plug, and I'll get Stumpy aimed over here. Hang on one second here. So this is the new LED plug. So this will actually plug directly into the power block onto the LED port. So once we cable this all up, you're going to actually see this plug, this connection, plugging into right here. And then we'll do that when we're ready to close the case up. That was two of the issues I found. The third thing, and once again, I kind of made an executive decision here. We had talked about the fact that the cable from Amazon that they shipped was the wrong one. Well, they came through for me. So they actually shipped the proper cable to me so that I could put the external connector on. So since we didn't need the switch on the power block, I eliminated the switch and I just put the power connection where the switch used to be. So here's what I'm going to go ahead and do. I'm going to clean up the inside of this a little bit, give you one more nice pass through on the inside, close up the case, and then I'll be right back with you and we'll take a look at the outside connections. Hang tight. Okay, folks, so here's what we're going to do. I'm going to go ahead and take Stumpy and I'm going to give you a nice, close, slow view over exactly what we've got built here. All right? So here's our this is our Kira. And I want to make sure he's focused in there so you guys can see that clearly. All right. So this is our USB connection. And this is actually wired directly into this USB connection that goes right into the Raspberry. The bottom USB goes over to an external port. The HDMI cable on the Raspberry is going straight here to an external port. The power plugged into the power block is going to the external port. And as you can see, it's cable managed nicely, so nothing will go flopping loose. So hang tight, we'll put this back together and I'll give you an outside view. Alright guys, and here she is, all nice and reassembled. Now I'll show you what we've got going here. Now you'll notice something I did, since I told you that I did not have a functioning LED, it was broken. Well, the only color LED I had was green, so I put a little bit of my own personal touch into this to kind of let it, let people know that it's mine. Alright, on the side we've got our two joystick ports there. And this actual switch right here controls what type of device you're connecting the Kira to. So if you're dealing with a Commodore, that always stays in the center. That is a USB port. Now that USB port, you could actually take this Commodore and plug it into any PC and use the Commodore as a keyboard, which is pretty darn cool. Alright, turn it around to the back here. And as you can see, we have covered the entire cartridge port. Challenging, but necessary. Right? We covered all the external peripheral ports, and we covered the video port. Here's our HDMI out, and this is going to be, remember we talked about our external card so we can change our operating systems. This is our power, and this is our external USB. And on this side, we have nothing. Nice and clean. So as you can see, very clean build. Very pretty. If you were from the outside, you wouldn't even know it had been modified unless you knew about the color of the LED. So let's go ahead and plug this thing in, and we'll be right back with you to do a smoke test. Hang tight. Okay, folks, now one thing I did forget to mention. Since we eliminated the switch, there are some specific power cables that you can purchase for Raspberries that have an external power switch. So that's what I elected to use. So the power block is wired on all the time, but the switch, you can actually turn it off and on from externally. So we're going to go ahead and fire this up, and let's see what we get on screen. Oh, now that's cool. One thing I'm noticing right off the bat. Now, I will tell you, folks, what you're going to see as far as the Raspberry image that comes up here is one that actually I've been working on for quite a while, so it's not your standard first fire off a Raspberry and it's going to work. So, but let's take a look at this. Let's let it go on in. Now, I will tell you one thing that I did choose to use. I've got a very, very good brand of wireless controllers. Now, I was going to use the Commodore joystick, the Atari joystick. We had actually talked about this. The problem I was having is it's got a couple of connections inside that are very inaccurate and probably just needs to be cleaned. So we may come back to this one at some point, but for right now, it's sort of, we don't want to use that. So we're using one of what I consider my stock joysticks for this process, okay? Now, these are wireless, and we use the external port that we were talking about to plug in the receiver on these. That's why you need that external port. Now, alternatively, I could have installed that wireless card on the inside of the Commodore, kept it with this at all times, and still had another external port to use also. But I elected to go ahead and use the one that we had just to kind of smooth things out. And I know this controller very, very well. That's kind of the reason I'm doing it. So what we're going to go ahead and do here. Now, what you're noticing right now is under voltage. I'm actually connected to a really low, I think it's like a 2 amp, so that's probably the reason you're seeing that right now. So now we can actually scroll through this using the joystick if we want to, or alternatively, I have actually mapped the keys on the Commodore to use W, A, S, and D, so you can do that as well. Alright, so hang tight. We're going to jump into just some random game, and we'll be right back with you. Now this game, folks, I'm pretty sure if you are a Commodore lover, did not come on the VIC-20, but it did come on the 64, and I spent a great deal of time playing this. Now, the cool thing about these emulators is you'll notice it actually emulates loading it as if it was loading it off of a disk. This is actually coming off of what it thinks is a disk drive. But not only does it emulate the game itself, but it emulates the time it took to load the game. So it gives you a real experience, the actual feel for what it was like. You can also use an emulated version of BASIC and write actual programs and store them on this. Pretty cool little function. Yes, folks, this is Impossible Mission. If you played anything, I guarantee you back in the day, you played this game for sure. So hold on one sec. We're going to get in here, and I'll bet you start to remember it a little more in just a minute. We're actually going to use, by the way, my joystick. So this allows you to actually switch between, and I'll show Stumpy here. It actually allows you to switch between the D-pad and the joystick just by hitting this button once. So I'm actually going to be using the D-pad just because that feels a little more natural with the way this thing platforms. But check it out, and I'll show you what we got. Yes, that would be Impossible Mission. One of my absolute favorite games from back in the day. I used to actually be pretty good at this, but at this point, you know, I did actually manage to finish this one time, but it's been a long time. I would say probably at least 30 years since I played it last time. So the idea was, all of the furniture here, you go up to it and you'd search it. The idea is you're searching for map pieces, and they will come and they will bite you. So you got to search them before they see you, or you run into them and then it kills you. So, yeah, about that. All right, we'll give this one more shot here, and then we'll call this one good to go. Yeah, there we go. And he'll see me and run, and I'll jump over his head, and then I'll come over here and search this one. Fortunately, they're not super intelligent robots. All right, so you guys get the idea. Pretty cool stuff, right? And this machine, like I said, as of right now, it's designed to emulate a bunch of different systems. Ideally, this will all be Commodore when I'm done with it. I'm going to create one image, specifically Commodore. I'm even going to try to have it boot into BASIC. Therefore, you have to load the BASIC commands to go ahead and launch everything. So that's my ultimate goal. But you can kind of get an idea of what we're looking at right now. Oh, and by the way, for those wondering, the little, I guess that's a pound key up at the top, would actually reset it and give you a different map. So that's actually what I'm looking at right now. See what I mean? I need to get this one wrapped up, and I'm sitting here playing this game. You got to love it. Because I had to fall down the hole. There you go. Anyway, as you guys can see, the Commodore list on this thing is actually extensive. Just to give you an idea, just the Commodore library itself, and I'm not sure how well you guys will see this, has over 5,000 games. And this is the Commodore VIC20, the 64, the 128, everything in one folder. So, and all of these games are playable from right here. The keyboard works exactly like it would in any Commodore game. So, it's fantastic. It really is. Guys, thank you so much for joining me for this project. It turned out to be a little more work than I had expected, but everything worthwhile generally is. That's kind of my motto on these. This is not going to be for sale. This will be on my permanent display. In fact, it'll probably be hanging out up here. That's the original box, but frankly, it's too cool. So I'm probably going to do some kind of a stand back here for it and keep it here. And throw down and play some games now and then, because it's a whole lot easier than pulling out the 1541, locating all the old floppy disks, loading everything all in one place. So there you go. Well, thank you guys again for watching. I really do appreciate it. Don't forget, smash that like and subscribe down there. It really does help me. And I did set up a new Patreon page, so feel free to support me on my Patreon page. Thanks again, and we'll see you soon.